He is involved in several research projects on biomass, upgrade, gasification and pyrolysis, liquid biofuel production, direct and external fire of gas turbine, and low temperature heat engine. And also he is a supervisor several PhD and MC student and graduated some of them. And he already published a large number of international journal papers. He is a reviewer several journals such as Applied Energy, renewable and sustainable energy reviews, and so on. Is also on like cleaner production, energy conversion and management, and published by supplier. And so he already have so many experience in biomass gasification process and also biomass utilization. We know Indonesia is we have several potential, big available biomass potential could be utilized. So we in this morning we will uh, we will uh, introduce our guest lecturer to provide to give us a presentation, a lecture on biomass gasification, and for all audience, please take more attention. And after the presentation, after the lecture, I will give all the audience to provide question Q&A. I think just write in the chat, write your question in the chat, and then we will give to the lecture today. And for Dr. Khalid, you have 1 or 1 and 30, 1 or 1 hour, half hour to give a lecture this morning. So the time is yours, Dr. Khalid. You can start the slide. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Assalamu alaikum and very good morning. Can everybody see the slides?
Yeah, okay.
Okay. So this lecture is not for the experts. I made it a bit wide range but shallow, so it will cover many topics, but it will not go deep. It will not go deep. So is for any person who wants to have idea about biomass and how to utilize it.
Yeah.
We will not be going very deep for this one. My name is Khalid Al-Hattab. You can visit me on my social media on www.aboutmealhattab. You can find me on Facebook, YouTube, and other social media. So Dr. Anis already introduced me. So this is just historical background very fast. My bachelor's degree is in 1998. Then in industry 6 years until 2005. Then in USM master degree 2 years until 2007. Then PhD until 2011. Then I went back to Yemen, did 2 years in industry, also in Sana University as assistant professor. Then I went back to USM since 2014 until now. So I started as postdoctoral researcher for 2 years, then as a lecturer and a senior lecturer in USM. So this lecture will include a general background on biomass definition, what is biomass. Then we'll have the conversion method, how to convert biomass into something useful energy. Then we'll have the power generation from biomass. We'll discuss 2 ways to generate power, either using externally fired engines, which is actually the most common way to generate electricity from biomass. Then the direct fire engines, which is usually not used or used for very small scale. Lastly, we'll have some background on biomass in Indonesia. I had some review paper with some lecturer from Indonesia, Dr. Jantar from Medan. So the paper is still under review. So I got some information from that paper. So Bismillah ar-Rahman ar-Rahim. Let's start the background. So what is biomass? Biomass is any organic material, mainly consists of three elements: carbon, hydrogen, and oxygen. So the sources mainly are the forestry. You have many forestry in Indonesia. You have the forest that help for furniture industry, timber wood cutting industry. So we have byproducts such as the leaf, the shell, the branches usually are cut on the site, are not transferred. Only the wood is transferred. So these waste materials like the leaves and the branches and all that, sometimes it is burned in open fire on the site, which is a big pollution. Second source for biomass is agriculture waste from palm oil industry. We take the oil, then we have the shell and other residues that are wasted. We cannot use them. So these are biomass waste also from other industries like the rice, the sugar production, sugar cane. We have the bagasse. Bagasse is the dry fiber. After you squeeze the sugar cane, you have the bagasse there, and other industries for agriculture. All industries has many waste that is not utilized. Sometimes it is burned directly to the ambient without utilization. So the specific characteristics of this type, which is the agriculture, it has very high cellulose and hemicellulose and lignite, which is very rich in oxygen. It's not like the normal fossil fuel. Normal fossil fuel, usually you have up to 90%, 80 to 90% carbon, and the rest is hydrogen, while oxygen is very few. In agriculture waste, it is different story. The composition are quite different. You have very high sugar-based materials, such as the cellulose, the hemicellulose, which is very rich in oxygen. You can see here the links. You have many molecules of OH and O. So the oxygen is very high, while the carbon is very low. Not very low, it's from 40 to 50% only. Then we'll have the third source is the animal waste. If you have a farm for raising animals, such as pig, cow, poultry, which is the chicken, you have the waste from these animals in the form of the manure or the dung. The waste is very high, rich in hydrocarbon, which is carbon and hydrogen mainly. You can see here, the formula is different. It's not like the agriculture cellulose. Here we don't have cellulose. Cellulose is digested by these animals, so their waste does not include that. So the oxygen content is quite lower, while the carbon content from these type of waste is quite higher in carbon. We can see here, this chain is C17H33, is a linear chain, so many 17 molecule carbon, then up and down, we have hydrogen. So the construction or the structure of this waste is different from the agriculture waste. Lastly, we have the human waste. Human waste in the form of the sewage. The sewage is thrown with the water, so it is very diluted with the water. Then it is accumulated in the sewage treatment plant. So this is a picture of sewage treatment plant, where sometimes it is just left to evaporate with sun, or sometimes the water is pulled for water treatment, while the solid material is left to go down to the bottom and sink. So after that, they collect the solid material. The other waste, we have the municipal solid waste. Municipal solid waste means any waste in your garbage. In your house, you put garbage outside. So this waste can be uh, biomass or can be non-biomass. All that is called municipal solid waste or the waste from city, okay? So it can be paper, it can be metal, glass, plastic, or biodegradables like the food waste. So if you have a recycling, you will make this utilization of biomass much, much easier. In developed country, they focus on the recycling inside, means in the building, in the house. You're not allowed to throw biodegradables, food, bones, whatever, mixed with plastic and with glass and with metal. You have to split. In developed country, usually it is all mixed. Then if you want to utilize, you have to build additional power plant or power station to separate them. So you have to separate the recyclables, then the non-recyclables, okay? So usually recyclables are all the four in the beginning: paper, metal, glass, and plastic can be recycled, while the biodegradable can be utilized as biomass. Okay, in most of the developed country, we have the land waste. So the land waste, we accumulate everything, just accumulate everything and put in a land waste. This land waste is big attraction for the animals, rodents. So you'll have the rat, the mouse, you have the cats, dogs, birds feeding there. So if you have this waste from hospital, for example, this waste can be contaminated with a virus and bacteria from hospitals. So whenever these animals go and feed there, eat the garbage, then they go back to the city, to the houses and spread the disease. So this is very serious matter in terms of the environment, also in terms of the health risk for the workers, also for the areas around these places. So you can see here, this is one of the land waste. Some countries, they bury underground the waste. Some countries burn, open burning. Open burning will cause another issue, which is the pollution of particulate matter and the haze and so on. So greenhouse and biomass, what is the relation? Is biomass good or bad? Is it good for environment or bad for environment? What's the relation between biomass and greenhouse? Fossil fuels, as we mentioned, has high carbon content. So it generates more CO2 from combustion. It's usually 3 to 3.5 kilogram of CO2 per kilogram of fossil fuel. While in biomass, we have very low carbon content, 50%, 40%. So the amount of CO2 generated from burning 1 kilogram of biomass will be around 1.5 to 2 kilogram of carbon dioxide. So carbon dioxide is the major component in greenhouse. Other gases also have, like methane, water, all are greenhouse, but CO2 is the major one. So what is greenhouse? Greenhouse, you all know, is if you have a glass house in the cold countries, they allow the sun to go in the house, then they don't allow the sun to reflect back. So they keep the heat. They allow the sun ray go in, don't go out. So this CO2 does same like glass. It allows sun ray to go inside Earth. Then when this sun ray or energy is reflected from Earth, it is not allowed to go back to space. So it is trapped inside the Earth, so increasing the temperature of the world. So you have probably heard about the global warming effect. Okay, so both fossil fuel and biomass generate CO2. Both generate CO2. But we hear often that biomass is neutral. it doesn't affect greenhouse emission. While fossil fuel is not neutral, it affects greenhouse emission. While both generate CO2, but one affect greenhouse, other doesn't affect. So it's confusing. Why is that? I don't think we have any time for interactive lecture, so we'll just answer the questions directly. So this is confusing. Why biomass does not contribute to greenhouse emission while fossil fuel contribute to greenhouse emission? Both generate CO2 in combustion. So you can see here from NASA website, the cycle of carbon, they call it the carbon cycle. It's not CO2, it is carbon, means carbon have a closed cycle. So you can see here in this picture, you have yellow color, which is the natural carbon cycle. You have red color, which is the human interaction. You have the white color here is the non-reactive in the cycle, means it doesn't go in cycle. So we can here see the photosynthesis process is a factory inside the tree. So every leaf of the tree has a factory that convert CO2 into carbon. Human can do something like that. You have the Woodward reaction to convert CO2 into carbon, but you need a lot of energy. So the tree takes this energy from the sunlight. So this is called the photosynthesis. So whatever carbon dioxide in the air, CO2, is taken by the tree and converted into carbon. This carbon is basically the fruit or the wood. So this fruit or wood can be either eaten by animals, then they burn it. So everybody has engine, millions of engines inside the body. They convert this fuel, biomass fuel, into energy, and the exhaust is CO2 again. So we breathe oxygen as the air inlet, then we discharge CO2 as the exhaust back to the atmosphere. So we basically engines utilizing biomass. Animal also do that, trees also do that. Also, you can see here, the microbial also have half of the cycle, 60 ton per year, 60 gigaton, sorry, this is in gigaton per year. So 60 gigaton is microbial bacteria taking this emission, while 60 gigaton is the tree. So we have here 120 gigaton per year is the cycle. So when you take biomass, either by eating the fruit or by burning the wood, you are inside this cycle. So you are not adding any neutral, any additional CO2 to the cycle. So the neutral is the net addition you add is zero, is neutral. While if you take fossil fuel from under the ground, and this fossil fuel has been stored under the ground for millions of years, it's been a dinosaur before, so it died, then it was buried for million years, then it convert to carbon. If you dig this dinosaur and take it back and burn it in fossil fuel, you are releasing new amount of CO2 that is not from this cycle. So this cycle net is 120. So people add this 9 gigaton per year by burning fossil fuel. Also, we have here 3 gigaton per year. This is by cutting the tree. If you cut the forest, if you cut the tree, you're disturbing the balance. You're adding more CO2 by reducing the number of engines that can keep the balance, okay? So fossil fuel produce CO2, but out of the cycle. So whatever fossil fuel give you will be addition. While biomass also produce CO2, but inside the cycle. So whatever biomass give you is inside the cycle. So inside the cycle, the net power, the net addition is zero. So that's why biomass is neutral, while fossil fuel is not neutral. Cutting the trees, deforestation will increase greenhouse by reducing number of trees that can do the cycle, okay? So biomass conversion, we have the first method is thermochemical. We have two words, thermo and chemical. Thermo is heat, chemical is chemical reaction. Then we have biochemical, also two words. We have bio means the bacteria or any living organism. Then chemical is chemical reaction. Lastly, we have the chemical reaction. Usually it has moderate heat or pressure to occur. So under thermochemical, we have many types, just burning, direct combustion to convert biomass into heat. Or we have something called a gasification. Then we have another thing called pyrolysis. Under pyrolysis, we have different types. That is not complete pyrolysis, carbonization and clarification. The fourth type is the hydrothermal and vapothermal, means you convert with heat, but in a medium, which is either water or steam. So this is hydrothermal or vapothermal. Then the biological, it could be a fermentation, is like we do the wine or the alcohol. People before just put the fruit inside a container, then let the bacteria do the fermentation and convert biomass into alcohol. So this is fermentation. Or you have anaerobic digestion, means in the absence of air, you convert biomass into methane or biogas. Lastly, we have the chemical reaction. We have a liquefaction. This is very old technology, will not go in detail. So this is a Fischer Tropsch liquefaction. Fischer is name of scientist. Tropsch also a name of scientist in early 1920s. They did this chemical synthesis process to convert CO2, CO and hydrogen into liquid fuel. So they use chemical reaction to convert the synthesis gas into liquid fuel. So this is chemical process. The last one is the esterification or transesterification. This is the biodiesel production process. So how you produce biodiesel, it depends on the raw material. You are using fat or using oil, we're using what? It will be either esterification or transesterification. We'll not cover this one also. We'll cover mainly the thermochemical process and some of the biochemical process conversion. Okay. Am I going okay? Should I increase the speed or reduce the speed? Okay. The rate is okay.
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 Yeah.
So first one is the combustion. This is thermochemical process, means we have heat and we have chemical reaction. Both are needed for this process. But this one needs additional agent. So this agent in this case is air doing oxidization. So the chemical reaction here is known as combustion. So combustion is a special chemical reaction to convert biomass fully into carbon dioxide, CO2, and water. So this is the full combustion. However, biomass fuel has a problem when it comes to combustion. It's not like high-grade fuels, fossil fuels. So what are the issues when we want to burn biomass? So first issue is the high moisture content. Biomass usually, if you have wood, wood is the driest, but still it has nearly 20% or 15% moisture. Other biomass has up to 90% moisture, which is extreme. So usually if you have like 90%, you cannot burn at all. You have to dry first, then you can burn. Why? Because water will take all the energy and you don't have any combustion. So also other downside is the hydroscopic behavior, means biomass, even if you dry, it tends to absorb moisture from air. It's not like the other materials that if you dry, it will keep the moisture as it is. Biomass, if you dry in oven, then you put in the air for 1 day, it's already wet again. So it absorbs the moisture from the air. This is another downside. Okay. So another downside when you want to burn biomass directly is the low energy density. This includes the heating value is low, also the volume is large. So this is the relation between the heating value and the volume. So for very large volume, you have very low energy. It's not like cool. 1 kilogram of cool can give you like 25 megajoule, while 1 kilogram of biomass could be from 10 to 19 megajoule. So this is a problem when you want to transport biomass, you want to store biomass. So that's why usually it is not feasible to do a central biomass power plant. Why? Because central power plant, you need to bring the fuel from far away, hundreds of kilometers away, by trucks or by whatever. But biomass, if you want to fill a truck, it will give you like a fuel for half day, a full truck, just fuel for half day. So it's not economically feasible because of the low energy density. So biomass power plants usually is only feasible if you are using inside, on the site. Means if you have palm oil mill, you take the waste and you have the engine there, the gasifier there, everything there, so you don't have transport, then it is feasible, yes. If you want to get a truck and transport biomass, you lose more money than you generate. So another downside is the poor grindability is not like coal. If you have coal, it is very brittle. You can crush a coal with your hand. Try to crush wood with your hand. You cannot do that because it has high moisture. So the grindability, you have to put too much energy in the grinder to convert biomass into other form like sawdust or pellets or whatever. Okay. Second process is the pyrolysis. This is also a thermochemical process, but in this case, we don't have any agent, just heat and chemical reaction, no agent at all. So you can do this one in vacuum. You can do this one in inert gas like helium or whatever other gas, nitrogen or helium that doesn't react. So pyrolysis is a decomposition. Mainly, if you put biomass and you heat, it will decompose. So pyrolysis is different types depending on the temperature and the time. So the common one is the slow pyrolysis, which is counted in minutes. So if you have low temperature, 400 degrees Celsius, you will have carbonization. If you have less than 400 degree, you will have torrefaction. But if you increase the temperature to 600 degree, you start decompose biomass into gas and oil. This oil known as bio oil. Okay, so pyrolysis does not need any medium. It can occur just with the biomass and the heat. No medium required. Other novel types are the fast pyrolysis and the flash pyrolysis. Fast pyrolysis from half second to 5 seconds, mostly generating gases and oils. Flash pyrolysis is less than 1 second, means you drop biomass in a heater, very intense heat, and it volatiles instantly and change into gas. So flash pyrolysis is a continuous process. You just pass biomass and it devolatize directly into gas. Then we have the subcategory for pyrolysis, as we mentioned before, is the torrefaction. Torrefaction is a way to upgrade biomass. We saw before the downside of biomass is low energy density and high moisture. If you want to upgrade biomass into a good quality fuel, but it's still not charcoal. It's not charcoal. It's still between charcoal and between biomass. You do something called a torrefaction. So torrefaction is a pyrolysis, slow pyrolysis, but with very low temperature. You need only 200 to 300 degrees Celsius for extended time. No atmosphere, no oxygen. You don't want oxidization. You can have nitrogen or helium or just a vacuum or a closed chamber. Then you'll have a torrefied wood, which is a brown wood. It's not black yet, it's brown wood, brown color. Then you'll have a carbonization, which is the charcoal production. You have many factories to produce charcoal. So charcoal production is a pyrolysis process, which is a slow pyrolysis at around 400 degrees Celsius up to 500 degrees Celsius. you don't have any medium. You cannot introduce air, otherwise you have oxidation and combustion. So carbonization is the next step after pyrolysis, after torrefaction. Gasification is the most common way to convert biomass into useful gas. So that's why the name is gasification, means you convert solid to gas. So gasification also is a thermofluid process, but it has agent. The agent could be air, could be oxygen, or could be other type of agent such as steam or CO2. That's why in some papers you have the confusion. Some researchers call CO2 gasification, call it pyrolysis. They don't call it gasification, because what is the line between pyrolysis and gasification? Gasification, some people call it partial oxidation. This is only if you use oxygen or steam or air. But if you use other agents, it is stepping towards the pyrolysis. So if you use CO2, you have a reaction called Woodward reaction that converts CO2 with biomass into a gas. So this gas is known as producer gas or syngas. So syngas is the synthesis gas. This is first introduced in early 1900s. They do cool gasification. So syngas is basically hydrogen and CO, carbon monoxide. You have diluted syngas if you have nitrogen and CO2 added. So the syngas will be diluted. But producer gas is a special case of syngas, which is diluted syngas from biomass gasification. Okay. So when air is used, you introduce nitrogen. So nitrogen is not combustible, so you dilute the fuel. So the fuel quality becomes very low. So once you use air as the agent for gasification, the heating value of your fuel, the quality of your fuel become very low, usually below 6 megajoule. So air is the most convenient, it's free, is most convenient, but the producer gas out will be low quality. It is only 6 megajoule and below. If you use steam, you don't have nitrogen dilution, so you will increase with the steam the quality of the gas. Also, if you use CO2, you don't have nitrogen dilution, so you'll have increase in quality. So using steam, oxygen, or CO2 as agent can reach up to 15 megajoule per meter cube quality of the gas. While air is more convenient and it is free, but you suffer from the low quality for the gas. Okay, so the gasifiers, we have the fixed bed, which is the batch type. We have updraft, downdraft, and crossdraft. We have fluidized bed, which is a moving bed with continuous feeding of fuel. It's not batch type. Then we have the suspension, which is either cyclone or the intern for large scale cool gasification. So we can see here the power scale. For fixed bed, downdraft gasifier is the most common with IC engines. Since the gas is clean, it has low tar and contamination. So it's usually used for IC engine, internal combustion engines. So it is between 10 kilowatt up to 1 megawatt downdraft. Then updraft, it has high tar content, so it's not useful for engine, but it's useful for boiler. So you can have heat for boiler. So it is usually in boilers, large scale, 1 megawatt to 10 megawatt. Then you'll have the fluidized bed. It is very high energy density device. So it can be small, but very high energy. So fluidized bed can be circulating or just bubbling fluidized bed. So you have a sand bed, then you blow the air, then everything starts to bubble like boiling water and mix the sand, hot sand with the biomass. Then you have the entrained gasifiers, usually only for cool gasification with very high intensity. So in this case, you use a pulverized cool. So like the powder shape cool, you throw with very high intensity. So you can see here a schematic drawing of the downdraft, updraft, and crossdraft. Crossdraft is not used. Most common is updraft and downdraft. So what we mean by up and down is the position direction of gas. If the gas go down, collected from down, it is downdraft. If the gas is go up and collected from up, it is updraft. So what's the difference? When the gas go down, this is the hot zone. So the gas get cracked, all the dirt or the tar is cracked, so you get clean gas. While in updraft, all the gas is pushed through the biomass, so it collects on its way many dirty things like tar. So the gas will be higher quality, but it will be dirty. You cannot use in engine. You only can use in boiler. Cross draft is in between. It's not as clean as downdraft and not as dirty as updraft. So this is the reaction inside a downdraft gasifier. You have the biomass. You drive biomass first, then you will have the vaporization from biomass, water vapor, and you have the air. So whenever you introduce the air, you will have the combustion zone. So combustion zone is just a generator for heat. So it generates the heat for the other zones. So gasification zone takes heat from combustion and takes some oxygen. Pyrolysis zone takes some heat from combustion, but don't have any leftover oxygen. Dry takes the least heat and no oxygen. So all takes from combustion zone. So this is for downdraft air gasification. Okay, biogas is the biological or biochemical conversion. It is anaerobic, means not aerobic, means no air. You just put waste food or waste from animals, manure, from cow or from chicken, and you store it and let the bacteria do its work. So it converts into biogas. So it can be a batch system, simple container underground you put all your waste and you shut down for a month. Then you open, you'll have biogas there. It is cheap, but it is not efficient. Or you can have a continuous feeding with the tanks and stirrers and so on. You can have different bacteria. If you run between 20 to 40 degree, you will have lower efficiency. If you run between 50 to 70 degree, you have different type of bacteria with higher efficiency. Then you'll have either single stage or multiple stage. Commonly now they have multiple stage continuous flow with many temperatures, so you can utilize different type of bacteria for this one. So we can see here, this is a simple batch type digester. So you put the waste from here and you close the cover, then the bacteria start to work and convert by fermentation and by degradation. Digestion is just like in your stomach. So bacteria generate biogas, which is mostly methane. Then you'll have the manure or the leftovers can be used as fertilizer for the plants and for soil. So biogas has a problem, contamination with sulfur hydroxide, which is corrosive. So you have to clean sulfur hydroxide first before you can use this gas in engine. Also, it has CO2. So you can absorb CO2 using lime or other methods. So you can upgrade the biogas into biomethane. So biomethane is upgraded form of biogas. So can be used directly in engine. Power generation, we have the direct fire and the indirect fire. So indirect or externally fire engine and direct or internal combustion engine. So in external fire engine, we have the steam boiler. It is the most common externally fire engine for biomass. It is like 90% of the biomass utilization of the world is steam. Very rare you find other types. Then you have the externally fired gas turbine. This is non-existence, only prototypes and pilot scales. Then you'll have the direct firing in IC engine with gasifier. Then you'll have gas turbine direct firing. Okay, so externally fired engines, you can see here we have a furnace. It's not a combustor, it's a furnace, it's atmospheric, it is simple, it's like a boiler. Then you have the tubes and you heat by biomass. So this medium could be steam, could be air. So if it is steam, it is called Rankine steam cycle. If it is air, it is called externally fired gas turbine cycle. Same idea. Okay, so you increase the energy enthalpy of the fluid, then you expand this fluid in a turbine. This turbine could be steam turbine or could be a gas turbine. Then if you let the gas or the fluid out, it is called open cycle. So steam cannot be let out. So steam is closed cycle. So you recycle the steam back, use here condenser to cool down back to water. Then you have a pump. So this pump takes the energy from the turbine, either directly with shaft or indirectly with electricity. So in a steam cycle, we have a pump. In gas turbine cycle, we have a compressor because we compress air. So this is externally fired engine. So the advantage of this engine, it is simple furnace, atmospheric, that can use any type of biomass. Even non-treated biomass can be just thrown in the furnace and you burn. So it's very simple type. No compression for the fuel, no injection, no automation, nothing. Then you'll have fuel flexibility. We just talked about this one. Then you'll have the open and closed cycle can be used. Closed cycle has the advantage of pressure. In steam, you can utilize the pressure using the closed cycle. You don't have atmospheric pressure. So you can do very extreme vacuum inside the turbine to utilize more pressure. And you can, in closed cycle, reach much higher pressure since you are not bound to the atmospheric pressure. Once you have high pressure, the equipment always becomes smaller. High pressure means low volume. So you can have a smaller turbine in closed cycle, while in open cycle, you cannot have that. So the disadvantage of the open cycle, the temperature is limited. For externally fired gas turbine, this is a problem since gas turbine needs high temperature above 1000. But if you use externally fired gas turbine, you only get 700 to 800, which is very low. But for steam is not a problem. So steam usually maximum is 500 degrees Celsius. You can get that easily with a boiler. So this is not an issue for boiler, but an issue for gas turbine. Then you'll have the high cost of the boiler, of the heat exchanger. Then you'll have the safety concern. If you have a boiler, then you have to call DOSH every year, the Department of Safety. You cannot live happily. You have to have inspection of your boiler every year. So it is a safety concern. Once you have high pressure boiler, you'll have to call the DOSH, the Department of Safety. Then lastly, this is not practical for small scale. Usually is above 100 kilowatt at least. Steam boilers are usually not efficient for small scale. So for small scale, we can use the other type, direct firing. So externally fired gas turbine, this is my baby in USM. I started with this one back in 2005. I did my master on this one. We got very low temperature and we couldn't start the turbine. So it was a failure. Then in 2014, a PhD student came. I was supervising him. He did 6-meter high heat exchanger and he managed to get 860 degrees Celsius air temperature. And the turbine successfully started, but you can see here the installation. This is 6-meter high chimney, then 2-meter system, then 8-meter, the whole thing. Every time you want to install, you have to call very big crane there. So this is the system. It is a gasifier combustor system with stainless steel heat exchanger, which is 6-meter high. The temperature is very high. You can see here, we let some space for turbine to go free, so the heat exchanger can expand. But still, you can see here, the heat exchanger is red hot, so it push the chimney up. It expand very high. Unfortunately, at 870 degree, this heat exchanger melted. So this is the downside of externally fired gas turbine. It is very expensive. It is still in pilot plan. Nobody is doing this one because it's very expensive business. So we have to redo this part again. So in 2018, another master student came and we did a new idea, which is called humid air turbine. Means we combine both externally fired steam and air. So you inject steam and you have air. So both will give you energy. Steam has the advantage, it doesn't need very high temperature. So a combination can work. So far, still not very successful. It's very difficult project. Okay, you can see me in my YouTube channel. I have all playlists for all the biomass lab. So this is externally fired gas turbine and other gasifier types in my channel, Khalid Al-Attab, so you can subscribe. Internally fired engine can be with IC engine or gas turbine. So the fuel could be very flexible, liquid fuel, gas fuel, or biogas. So advantages, it is a compact system with low cost. It is more suitable for a small size. So we have in USM this type. We build in USM. We have a gasifier, then you have the gas cooling, then you have the gas cleaning, then you have the engine. The engine, usually the gas enter at 40 degrees Celsius and we clean from tar first. So it has elaborate gas cleaning and gas cooling before the gas can run the engine. So we have a commercial offer in USM, 5 kilowatt system ready for order if you want to order. Also, we have for lab demonstration, we can build for you a 5 kilowatt system, ready system, downdraft gasifier with the cleaning and cooling system and the engine. Also, we have in biomass a power plant still not running yet. It is 200 kilowatt power plant. It has 3 gasifiers. And this is very elaborate cooling and cleaning system you can see here. Then we have the engines, 200 kilowatt engines. Then you have the biogas. Biogas usually is used either by a farmer who has cow or chicken or something. Then he has the waste. Then he can use this to produce biomethane. Then this biomethane should be cleaned, as we mentioned, from sulfur hydroxide and from CO2. Then it can run the engine. In this case, you can use the water radiator for engine to heat up the system. So if you want to control system 70 degrees Celsius, you can use your engine as the heat source, as a jacket, water jacket around the tank. So you can have this combined heat and power system. So this is available if you go Asia Biogas. They have 200 plus projects in Thailand, in Indonesia, in Malaysia, in Philippines. Mainly is biogas project with farms, cow farm, pig farm, poultry farm, and so on. So you have here microgas turbine engine. This is direct firing. This was done in USM. You need a pressurized gasifier because the gas turbine needs high pressure fuel. It cannot run in atmospheric furnace. It needs high pressure fuel. So the more economic type is to pressurize the gasifier. Means you pressurize the air, clean air. You don't pressurize the fuel because the fuel is contaminated with nitrogen. So it will not be economic for you to pressurize the fuel. So you pressurize the gasifier. In this case, you don't have to have a cooling system. You can use hot gas, but you still have to use hot cleaning system. So you clean the gas from particles and from tar is not an issue because it's hot, but you have to clean first in filter from particles. Then you can use micro gas turbine engine or large gas turbine engine and produce heat for steam generation or hot air generation or whatever, and electricity. So this is combined heat and power. This is a system built back in 2008 using pressurized downdraft gasifier and two-stage microgas turbine with a cyclone combustor and heat recovery. So this one was pilot plant, 1 kilowatt electricity and 35 kilowatt hot air. Then you'll have biomass direct firing with IC engine with liquid fuels. We have many engines running in IC engine lab. I don't have pictures. Also, we have microgas turbine running with liquid biofuels. It's much easier. You don't have to convert to gas or anything. You just use the liquid fuel directly. So the liquid biofuel usually does not need significant modification on the chamber unless it is low grade. So you have to modify the gas turbine or IC engine chamber. to cope with the higher viscosity. Usually these lower grade like palm oil or whatever, very high viscosity, so you cannot pump it and spray it easily. This is another project last year finished, PhD student. He did liquid biofuels, microgas turbine engine. You can see it in YouTube. We managed to run 100% palm oil fuel with this gas turbine engine. So you can go to my channel and watch the different experiments with this microgas turbine engine. So biomass in Indonesia, finishing here, okay. So biomass in Indonesia, we have this from my review paper. So you have in Indonesia signed, as Malaysia also, in the Paris Agreement on the intended national determined contribution to greenhouse emission global. So every country has to sign with some number target. They will reduce CO2 emission, greenhouse emission by how much? So Indonesia agreed to reduce by 29% by 2030. Okay, so this target, how to achieve this target? You can see here, the electricity demand with the population is increasing very fast. So some researchers say that by 2030, the electricity demand in Indonesia will be tripled, three times electricity demand as now. So how to reduce CO2 emission, while the electricity demand power generation is increasing? So you can refer to the Energy Outlook of Indonesia 2019. This is the link, or the Statistics of Indonesia 2019 for the statistical data. So here is the electricity production in Indonesia by the end of 2018. So this is for 2019. So we can see here, coal is the most contributor to the electricity power generation. You have coal power plants, which is gasification boiler power plant, means two-stage combustion gasification coal power plant. So 65% of electricity is the coal power plants. You have here biomass power plants is 4%, is okay, but most of it is natural gas and coal. The other types of renewable energy, we can see here, renewable energy contributes 40%, 14%. Half of it is hydropower, means you have a river, then you have large hydropower. So 7% is hydro, while the rest, solar, wind, biomass, are 7%. Biomass in Indonesia is good. It has many power plants already. So it is nearly 4% production from steam boiler biomass power plants, externally fired. So the other sector contributing to the CO emission is not the electricity only. You have the transport section, which is the largest section after electricity. So transportation, you can see here now, Indonesia, how much they consume using fossil fuels, while electrical commute, the electrical trains, and very low. Also, the natural renewable energy is very low. It is expected by 2050, this one to triple the demand for transport. So these guys in Indonesia Outlook, they did simulation and they simulated 3 cases. First case, they call it business as usual, BAU, business as usual. So if you keep as you doing now, this is the result. Then they simulated other cases, low carbon case and sustainable case. If you go low carbon case, change the policy, low carbon case, you can achieve this target 29% CO2 reduction by 2030. If you keep business as usual model, which is this one, business as usual, it's not expected that Indonesia can achieve the target of greenhouse. So biomass in greenhouse, we have the public usually view biomass as dirty fuel. Biomass is misused, not used correctly, is a dirty fuel. But if you use it correctly, it's not dirty fuel. It's very environment-friendly fuel. So the issues with biomass, we have here the effect of biomass in greenhouse. We have the forestry. You have the household cooking. You have the waste management. Waste management, we already talked about the landfill and so on. Then lastly, we have the liquid biofuels and power generation. So forestry, as we mentioned before, if you cut forest, you increase the CO2 in the air because you reduce number of engines that can convert CO2. So you increase the global warming by reducing the forestry. So by 2014, one study showed that 60% of Indonesia greenhouse emission was contributed by the forestry, the cutting of the trees. Then you have here any action by the government should include a design of rehabilitation of the forest, banning the illegal cutting of the forest, and also the intentional burning of the residues of the forest. Then you'll have other suggestions by researchers. Mangrove forestry has 3 times the density of carbon compared to other forestry. So it can store carbon much more than the others. So if you plant forestry other than the one cuts using mangrove, you'll increase the reduction in CO2 by 3 times. Lastly, there is one method proposed by one researcher, the use of wood as a storage. So if you cut the tree, but you store it as a building material for house, so it will remain there for 70 years. So you store carbon for 70 years. So this is negative reduction of CO2, means biomass in this case is not neutral, zero, it is negative, means you reduce CO2 in the air by storing carbon. So how to store carbon? One of the ways is store it in wood. Household cooking, early in 2004, 89% of population used kerosene mixed with biomass open burning stoves. Then the government introduced in 2007, 2008, this campaign to promote LPG. They distributed stoves and they give free LPG to reduce the health risk for the residues from the smoke of biomass open burning in cooking. So another campaign was so this one LPG, it increased by this campaign from 10% all the way to 47%. And the kerosene used for cooking reduced from 36% to 9% only. Programs such as the biomass cooking stoves, also initiated by the government, but was not successful. So what to do? You can see LPG stove is a good move. It is clean fuel. Also, if everybody has LPG stove, you can later on introduce the biomass fuel as a pipeline. So biogas or biomass can be introduced to house as a pipeline. Then you can use your own LPG stove for cooking. So a mid stage is LPG stove is a good move. Then you can introduce higher technology of biomass gasification using pipelines inside the house. Liquid biofuels, we have in 2006 initiative, National Biofuel Development Team, Team NAS. It was initiated. So the target is to increase the contribution of liquid biofuels in Indonesia. So by the presidential, we have the presidential regulation, the target for bioethanol, which is from fermentation of sugarcane or other into ethanol. So bioethanol mixed with gasoline used for car or bus or trucks or whatever. The regulation target is to reach 20% ethanol and 80% gasoline by 2025. So liquid biofuels, materials for bioethanol is usually the sugarcane, you have the sweet potato and other materials. For palm oil, for biodiesel, biodiesel is different. It's not fermentation, it is chemical transesterification. So it's different process. You have the palm oil, or you have the non-food grades like the jatropha, also the rubber seed. So you avoid the conflict between food and fuel. So if you want to increase the target for liquid biofuels to cover the cars in the transport, you have to plant more palm oil and rubber seed. So the issue is you cannot use the forestry land to do that. Otherwise, you will have negative effect on CO2 greenhouse. So you have to find other lands, free lands, to plant extra plantation to do the liquid biofuels industry. So this one research proposed the mobile processing, and they study the economic feasibility of a small mobile station on a car. So these people go from city, from village to village, collecting from farmers this rubber seed, then producing biodiesel, then sell for the farmer the biodiesel to run their diesel engines. They found this one to be economically feasible with transport unit, small, trans-esterification, moving, distributed in the villages. So they don't have to collect the biomass and transport it. They convert it on site. So this is some of the power plants in Indonesia currently. You can see here, all of it is steam. There is no gasification yet. Hopefully soon there will be gasification and IC engine, but yet it is all either combustion or gasification boiler. So you have here the location, many cities. Then you have the capacity and the type of fuel used in Indonesia. This is nearly 4% of the grid power is generated from biomass power plant, which is usually a steam, externally fire, not direct fire. Okay, thank you. We can open for Q&A.
Okay, thank you, Doctor. And next, if you have a question from audience, please write your question from the chat. And or if you want to ask directly to the lecture today, please you can ask our guest lecture today. Uh, Maybe one or two questions in the case this time. No? Okay, I have we have still one question from the chat. This is this question from Khairul Ali Alatas. Thank you for the question. Um, okay, hello Dr. Khalid. I want to ask about the effect of biomass toward the environment.
For
How about the effect of biomass on the environment?
the
To do have to do more pre-treatment. I think have to do more pre-treatment to suit the condition. How about the effect of biomass to the environment?
okay.
And we have to do more pre-treatment or how?
Okay, I answer now.
Okay. Yeah.
Okay. So biomass, from the perception of people, is a dirty fuel. It is usually a waste. It is a waste material. Could be waste from your house, or could be waste from industry, or could be waste from agriculture, or whatever. So if you just leave the biomass there, it will collect rodents, insects, and diseases. If you burn it in open burning, you will have another problem of the smoke and so on. So to deal with the biomass systematically, either you have option of biogas digestion. This is usually special for high hydrocarbon content material, such as your food waste from your house. You cannot use the low plastic or other materials, only food waste or animal waste. This one you can use digesters, means just a container. You put the food there, you close it for a month, then you open after a while a pipe, you'll have a biogas coming there. So can be in villages, a simple homemade device to collect biogas. Then this biogas, you can use it for cooking. Uh, More systematic work with biomass, you cannot do usually a homemade. It should be a system using conversion of biomass into a fuel. So this one can be simple as a simple stove. So in stove, you can have downdraft type or inverted downdraft type to convert. Usually we have FYP projects doing this. It's not very difficult. You can find the designs from internet, and usually the biomass stave is very simple. You can design, so you can use your waste to convert into heat for cooking using biomass stove. The problem is the open burning. Open burning is not good. Usually we have the open burning for residues can have in hot months can spread into a fire. So the fire can have disastrous consequences. So open burning usually is not recommended.
Okay.
Okay.
Okay. Thank you. Um, Other question, please. If you need to ask directly to Dr. Khalid, please unmute your audio and then uh, please provide deliver to Dr. Khalid. Any question from the audience? Oh, in this chat, we have the question from the chat. This is from Rifka Himawan. How about the issue? About the issue of sustainability of biomass to substitute the fossil fuel to produce the power generation. The issue of sustainability.
Yeah. Okay, I answer this question.
Yeah.
Okay, so many researchers do this life cycle economic analysis for sustainability of biomass project. Usually biomass project is not feasible unless it has many factors. First factor, you should have the fuel without transportation, means you should have a factory that produce the waste or a farm that produce the waste. You cannot have a central power generation. Usually all the existing power plants are on the spot, means you have palm oil mill, then you have the oil shell and other waste, then you can have a successful, sustainable power plant for biomass. Or you have a farm, you are a farmer, you have many cows or others, then you can go for biogas power plant, then you can collect the gas and run engine or for cooking. So the sustainability of biomass depends on the source of biomass. If you have the source of biomass, then you can invest in the spot, then you can have a successful, sustainable business for biomass. Liquid biofuels is different question. Liquid biofuels is usually a government plan. You should have a plantation that is many hectares, especially for liquid biofuels, so it doesn't conflict with food. So you don't take the plantation for food and take it as fuel. You have a separate plantation to produce liquid biofuels. Then this liquid biofuels can be used directly in transportation as bioethanol or as biodiesel. So biomass sustainability is not always good. it has many restrictions. So before doing business with biomass, you have to do the economic feasibility study. How much you have waste? Do you have enough waste to build investment system? Then you can go for the system. For sustainability for greenhouse, as we mentioned, there are 4 factors for greenhouse: forestry, liquid biofuels, power production, and house cooking. For Indonesia, if you keep cutting the forestry, you cannot achieve the CO2 target, because the forestry is the engine that reduces CO2. So stopping cutting the forestry is the first step. For others, biofuels, for example, you have to plan where you put the hectares of plantation. You don't put it in forestry region. You put it in free land. Then, yes, you can sustain CO2 and get the target for CO2 emission. Okay?
Okay. Thank you, Dono. Next question from Akmal Putra. This is about uh, processing of biomass via pelletization.
The
Can be
what?
biomass be converted using mechanical processes? Can biomass be converted using mechanical processes such as pelletization, purification atau pellet, like a pellet
Yeah, yeah.
biomass?
This is usually is not a conversion. This is a pre-treatment for biomass before use. So biomass usually is not suitable directly for your system. You have to change the shape of biomass mechanically. So either you make it sawdust, or you make it into pellets, or you make it into briquettes. Sometimes it is leaf, like the grass or leaf or rice husk, is very, very not dense. So you'll have 1 ton occupying like a full house. So you don't want this volume. You have to compress this volume into pellets or into briquettes, small pellets or small briquettes. This is not very expensive. Briquetting machines are available from China, very cheap. So you can buy briquetting
Yeah.
machine or a pelleting machine that compress the biomass and increase the density of biomass. So you can reduce the volume and increase the power density, power volume. So this is not a conversion. This is just a pre-treatment for biomass to store. Usually, if you want to store, you have to pre-treat first, convert into pellets or into briquettes. Then you can store, then you can use in gasifier or stove or whatever. Okay.
Okay. Thank you. Okay, Doctor. This is the next question from Bekti. Bekti Enggar Rahman about comparison of biomass energy and other renewable energy like hydro energy and other natural energy
Yeah.
in terms of power plant generation.
Yeah.
Yeah.
Okay. So resources for renewable can be general, anybody has it, or can be specific for different countries. So different countries have specific biomass, such as geothermal. You need to have geothermal. You cannot get geothermal if you don't have geothermal in your country. Hydro, you need to have hydro. You cannot have a river from nothing. Your country should have a river. Otherwise, you cannot have hydro. So these special type of renewable energy are specified to geographic regions. So some regions are rich with hydropower, many rivers. Some places are rich with this geothermal energy. Indonesia is rich of all. It has rivers, it has hydro, it has everything there. Biomass is different. Biomass, you can plant biomass if you don't have biomass. If you have, like Indonesia, many plantation already, and you have agriculture business, then the waste can be used biomass energy. The advantage of biomass, it is 24/7 generation, means it's not bind with the time. It's not like wind energy or solar energy, where if there is cloud, there is no power. If there is night, there is no power. If there is wind, there is no power. So you need battery to store. Biomass don't need battery. Biomass is 24/7 energy. And it's not constricted like hydro. Countries without trees can have biomass from their municipal solid waste. Countries don't need only trees. Countries can use farms, cow farm, pig farm, poultry farm, can use municipal solid waste to do biomass. So everywhere in the world, all countries in the world can have biomass. It's not restricted by country. The other advantage, as we mentioned, that biomass is 24/7, is like a fossil fuel availability. It is available whenever you want. You want power, you burn. You don't want power, you shut down. So it is available. It doesn't need storage like other type of fuels. Wind energy, only specific regions in the world has enough speed of the wind. Also, it is not 24/7. Solar energy also, if you have countries with many rainfall seasons, solar usually is periodic, so you need expensive batteries. Even if you put all the houses, you put solar power in the houses, you connect it to the grid, it is fluctuating. You need either a battery in the house or a connection, smart connection to the grid. If you have a smart connection to the grid, this is the best solution. Means the grid can control your power plant on your house. But this is very expensive, is infrastructure to do that. Okay, I hope this answered the question.
Thank you. I think we have still a lot of questions. This is come from Norik Rajas. Uh, he asks about if it possible for biomass to replace the fossil fuels in the future. Is it possible for biomass to replace the fossil fuel in the future? If it is possible, when do you think it will happen?
Yeah, okay, I answered this question. So you can go to the link in these slides, the Outlook. They have simulation. They simulated 3 cases, business as usual, and the most promising one is the low carbon plant simulation. So if you use low carbon simulation by this Outlook Indonesia, they predict that around 50% of the power will be from renewable energy by the year 2050. So this is a simulation based on several assumptions. If the government do certain policies, Indonesia can reach up to 50% renewable resources for electricity by 2050. You cannot reach 100%. You have very cheap coal. You have natural gas. You cannot just sacrifice your economy by not using fossil fuel, while other countries doing greenhouse like crazy, then they ask Indonesia to do all the greenhouse. So it's not fair. So every country has to see its benefit and contribute to the global in a fair share. Means the countries like US and European Union should have the most higher share in greenhouse, while developing countries should have less share, because those countries are the source of pollution of greenhouse. They have the factories, then we have the catastrophe and global warming. So if we go for this business simulation for low carbon, uh, by the simulation, Indonesia can achieve 50% by 2050. But this one is the government is committed to renewable energy, not only biomass, renewable energy. Indonesia is very rich with solar, with hydro, with geothermal, many sources in Indonesia. But even that, fossil fuel will be still there. Fossil fuel is not going anywhere. Fossil fuel is there, is cheap. You can have it anytime as a reserve. If
Mm.
something happens, you have the reserve. So you keep it as a reserve for yourself.
So the
Okay.
utilization is still the big problem, Doctor.
Uh-huh.
Okay, thank you. Next, from from Junaid. Junaid Khan asks about the disadvantages of cross gasifiers.
Mm.
What are the disadvantages of the cross gasifier?
Yeah, cross gasifier
Hmm.
is my baby. I use it in my externally fired gas turbine. It has some problems that the char particle can flow away, so it's not contained as the other types. Updraft, you don't have
Hmm.
any char can go up because the gas is going up, but the tar is high. Downdraft, you can have some char, so the conversion efficiency must be low. You can have some char dropping without converting, but the gas is collected clean. Cross draft is has the problem of some char can escape since the output of biomass, output of the producer gas is very close to the combustion zone. So I use this cross draft in my externally fired gas turbine engine using gasifier combustor, which is a cross draft gasifier with a combustor. But since I have a combustor there, so drifting char is not a problem. I can burn it. So this one can be used for thermal output, no problem, but is a bit difficult to use in engine. You need a cleaning system to separate the particulate matter, which will be higher in cross draft compared to downdraft. Okay.
Okay, thank you for the. Uh, we still have oh still have two questions. Okay, this is from Rifka Himawan. Second question, I think this one. He asks about the power sharing, the power share of the biomass to the fossil fuels. For example, the main source of the fuel in Indonesia is the coal, the charcoal, still the main source to produce the electricity in Indonesia. So how about the biomass power in substituting the fossil fuel? Yeah.
Okay. So in
Indonesian cases.
2008, you want the share, power share, right?
Yes, power share.
Okay. Indonesia has a lot of coal. So coal is Indonesia is cheap. They don't import, they even export. So it is cheap way to produce electricity. Biomass, you should not count forest as a biomass because it is necessary for the CO2 cycle. If you cut some regular cutting by replacing what you cut with new forestry and use this tree for furniture is okay for furniture industry. Then you have the residues from this furniture industry is the biomass, but the forestry is not a biomass. So biomass resources mainly is from agriculture in Indonesia. Agriculture mainly is the palm oil industry and rubber seed and other industries. So by 2018, the share is 50% coal and around 4% biomass. It's still very low, but the potential is much higher. This one is just the utilized one. The potential for biomass waste is huge, is not utilized yet. So many palm oil mills don't have power generation. They just burn the residues or just throw the residue into landfill. So the potential is there. The potential is there for power generation from biomass, but currently the share is 50% is coal, and biomass is only around 4%. Okay.
Okay, thank you. Um, we still have two questions. Next
Okay. No
question.
problem.
This is from Bagas Wijaya, the second question. And also from Hairul Ali Alatas. This is I think the same cases from Bagas and from Hairul Ali Alatas
Uh,
about the challenging problems of gasification technology
mm,
for urban area,
uh,
and also uh, what is the difference of biomass from forest residue and from corn biomass, corn stubble, I think, or another.
the
So the
second question
forest
is
residue
again.
and
The second question again.
the second question is the difference of biomass from forest residue
Uh,
and from corn,
corn.
corn
Okay.
stubble like that, corn stubble biomass. Yeah, forest tree,
Okay.
woody biomass. Yeah.
Uh, okay. So first one is the gasification challenges in urban areas. Usually gasification uh, is for small scale. It's not like the externally fire engine, steam, large scale. So gasification can be used directly in landfill if there is a company willing to do gasification for the waste, either for municipal solid waste gasification or so this one could be by the government usually, or a big business. If a big business has the capacity, the capital to do gasification in cities, so usually this one should be associated with other facilities such as the um, sorting the waste, plastic alone, metal alone, glass alone, then biomass. Then you can have, so you have two companies usually. One is sorting the source, then the other is utilizing the other source to generate electricity. So gasification can be one part, but it is expensive technology, is not very cheap. That's why people use boilers, is much cheaper and more reliable. People are very familiar with boilers, but boilers, as we mentioned, sometimes the technology of combustion is not good. You use old design boiler, so you have smoke. Also, you have the risk factor of the high pressure steam. So you cannot use it in urban areas, in popular areas. You can only use it in very far farms or something. So gasification in this case is more suitable. Gasification has more safe and controlled manner of converting biomass into gas. Then you can use engine for generation of power. But this one usually is not individual, is usually a company or the government doing these power plants. In USM, we produce 5 kilowatt for house if you want to buy. So this one is very small. You can just throw your garbage inside every day and you get your electricity. This is 5 kilowatt compact system. Okay. For the second one, forestry and the woody and the corn is different thing.
Yes.
Forestry is different. Corn is different. Corn is agriculture, is not forest. So usually the forest is the production of timber or furniture. Means if you cut wood for for furniture, house furniture, or for building houses with wood, or for timber, this is forestry called. Other trees, if it is used for agriculture like rubber seed, or you have corn, or you have sugar cane or palm oil, this is not considered as forestry, because this one is every 5 6 years you cut the trees, then you replant again. So this is based on a periodic grow of these trees. It's not like forest. Forest you grow for 100 years, no problem. But these small trees for agriculture is usually under uh, temporarily growth. Means you have these hectares, then you cut after 5 years, then you replant again for this agriculture industry. So the waste, when you cut, the waste usually is not used for timber. You cannot use these corn or palm oil or sugarcane for timber. The wood is not there. So you use first for agriculture, you produce oil palm, you produce sugar, you produce corn oil, you produce other products. Then the byproduct is biomass. Biomass is not the product. Biomass is the byproduct, the waste. So the main purpose for this one is to produce in a factory. This is food industry. So you produce food from these factories, then the byproduct is biomass. While forestry is different thing. Forestry is for 100 years. If you cut some trees to do furniture, you have to replace them with new trees. But agriculture is different. You can cut, no problem, because it's usually temporarily. 5 10 years, then you cut the whole farm, then you grow a new farm, because after 10 years, it doesn't generate any fruit anymore. Okay?
Okay. Okay. Thank you. I think from the chats already all of the questions have been uh,
Mm.
already explained.
Okay.
And for the last uh, opinion from Dr. Khalid, because about the municipal solid waste, like municipal solid waste already presented, and this, that is provide serious problem
Mm.
uh, due to like direct combustion like this, uh, and also other thermochemical treatment. So the thermochemical treatment like gasification, pyrolysis, torrefaction also provide several advantages, but also have some disadvantages. For example, outdoor pollution. Uh, Outdoor pollution is a serious problem also. Particularly from pyrolysis process like it. So how about reduce the odor pollution? Not, although the gas you can use as a fuel, but the odor itself still like smelly.
Yeah, yeah.
How about you? Okay.
Okay, so you want to discuss the municipal solid waste downsides.
Yes, down treatment.
Okay, yeah, the pollution and okay. So for municipal solid waste is the urban waste from city, from your house. In modern life, most of it is plastic, while few amount only is digestible or degradable hydrocarbons like food waste. So food waste usually is digested before it go to the landfill, while plastic is there. Plastic is remaining there.
Mm.
Not all plastic can be converted. Some plastic has toxic materials. If you want to burn plastic, you'll have very high pollution. So you cannot burn plastic. So the best solution for plastic is recycling. But if you don't have a recycling power station, means a plant that separate glass, plastic from the other degradable waste, then one option for certain type of plastic is to do pyrolysis. So pyrolysis of plastic waste is very promising technology. to convert the plastic waste into fuel. So this fuel could mostly be a biofuel, which is the oil biofuel. But the byproduct, you have the gas from this process is toxic. So if you have a power plant for pyrolysis, usually they have this measurement to clean the gas or burn the gas. Also, not all type of plastic are advisable for pyrolysis. Some are not cannot be pyrolyzed safely. You have toxic material there. You cannot pyrolyze that. Then that one only you have to recycle for the industry. For the other municipal solid waste, uh, if you put this garbage in a can for a week, usually all the digestible material is already digested and the bad smell is out already. So you'll have the health issue from there. So for digestible or high hydrocarbon content, they have to be put separately from house. They have to put separately from house. Either you use carbonizer. We have in USM one design for carbonizer commercially also for kitchen waste. So kitchen waste, bones, rice, meat, whatever you have there, cannot wait for a week or 2 weeks. It will turn into methane and many bacteria. So there are other ways to utilize this one. The best one so far is the carbonizer. So the carbonizer can just heat these and devolatiles all the moisture and convert it either to charcoal or less brown material that can be used for barbecue or you sell as a charcoal or whatever. So these carbonizers are starting to become popular. We produce and use M1 carbonizer commercially. It is I think I'm not sure how much, but it's like for restaurant 1 day capacity. It can do the carbonization for all cooking waste. You just put inside the carbonizer and convert into charcoal. Then you can store this charcoal no problem as a fuel for any uses. For plastic, there should be a sort. The plastic that can be used for pyrolysis, you can use it for pyrolysis and produce fuel, which is the bio oil. Other plastics that has other toxic material or metallic components, such as electronics, that has to be recycled. So recycling is another issue. In landfill, if you just burn it to the ambient, you will have many toxic material fumes going into the
Sometimes,
ambient. Yes.
sometimes during the process, the odors generate from the gases like that.
Mm.
So, mm,
You want to collect pyrolysis gas.
yes,
Okay. The pyrolysis gas is not like the gasification gas, is slightly different, but this gas has also a heating value. So it can be used as a fuel. It can be used as the heat source for pyrolysis. Means a simple design of pyrolyzer, you don't need electrical heater. You can use a stove, then use the gas from the pyrolysis inside the stove. So this pyrolysis gas burn and heat the pyrolyzer. So you'll get the output will be the oil, but the gas is a byproduct as input power to this pyrolyzer. Means you can use a plastic to generate oil. Then whatever fume gas you can collect doesn't condense. Usually you condense all the gas. Some very light gas cannot be condensed. So this light gas can be burned under the stove. So it can provide the heat input for your pyrolyzer. So this pyrolyzer is very simple. It's
how
just
about the storing process, doctor? Storing process, like for example, compression, like compression,
for what?
storing like that, is it possible or not? Compress
Storage
the
of the
gases,
gas.
yes, compress the gases, and we store
Yes.
it
Of
for a
course, you
long
can do.
time. Yes.
Yeah, the storage of the gas usually is if you want to use a compressor, you need to clean the gas
Mm,
first. So cleaning the gas, you will take some effort to clean the tar and all the content before you can enter to a compressor. Otherwise, the compressor will jam and will. So if you want to store the gas for pyrolysis, is better than gasification because pyrolysis don't have contamination of nitrogen, while gasification has contamination of nitrogen. So producer gas storage is not very economic, but pyrolysis gas storage is much more economic since you don't have any dilutant material that don't burn. All the gas burn. You don't have nitrogen there. If you have a batch system, in first 5 minutes, all the air will be out. Then you'll have a pure gas, but you will have some tar. So you'll have to clean the tar first. Then you can compress the gas and store it. So it is economic in this case. Okay.
Okay, thank you very much. Okay, right. I think the time is up.
Mhm.
So, once more, thank you for the time and more valuable information from Dr. Khalid today. Hopefully, all audience, particularly the student, can study biomass energy plus more and more.
If you are interested in biomass project in USM, you want to come do study here, or you can visit my
Yes.
YouTube website and see what we do in biolab, different experiment. You go to YouTube and
Okay.
watch.
Okay. I think you can share the link maybe to
Mm.
your website for students. Next.
It is actually the first page, www.aboutme.
Uh,
So this link is my gate. It's like a door.
okay. The
You go to the
keywords, I
door,
think.
you
The
can go
keywords.
to what to any website or YouTube or whatever. So my door is this
Uh,
about me. You can go from there to my website or Facebook or YouTube or whatever, LinkedIn,
okay.
ResearchGate or whatever.
Okay. Thank you very much. And I think we have finished this program. And for audience, thank you for your uh, in this in this activity. And then uh, finally, thank you, Jane, for all of you. And wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much. Wa alaikum assalam wa rahmatullahi wa barakatuh. Okay. Assalamu alaikum.
Maybe before I leave this program, I think we take a picture maybe from
Okay.
several slides here. So
Yeah.
please, all audience, on your camera. Uh, please to on your camera to take the picture from slide one, okay, to six. Okay, okay, okay. Thank you. Slide one from three, two, one. Sorry, tolong. Okay, thank you. Next slide. Slide two. Okay, one, two, three. Okay, next slide three. Yeah, one, two, three. Next, two, three. Okay, slide five. One, two, three. Okay, last already. Okay, thank you. Okay, thank you very much for your attention and attendance in this program. I think next program like this we will arrange again, and hopefully Dr. Khalid will have time to provide a lecture in our study program here.
Inshallah.
So, and also to enhance our collaboration
Yeah. Thank you. Thank you
from
for
our
inviting me.
institution between Universitas Negeri Semarang, and also University Science Malaysia. Thank you, Doctor.
Yeah, thank you very much for the invitation.
Welcome.
Okay.
Thank you
I will
very much,
contact you again
Dr.
after
Khalid.
this program. I will
Yeah,
contact via
contact
WhatsApp.
me. Okay, thank you very much. Assalamualaikum warahmatullah.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Thank you
wabarakatuh.
very much, Dr.
Thank
Khalid
you.
and
Oke,
Dr. Samsudin Anis. Terima
Thank
kasih.
you.
oke.
Terima kasih.
See
Terima
you
kasih
later.
Pak
Thank you.
BD3.
Insyaallah.
This is our Vice of Dean, Dr. Wirawan
Oh,
Sunggodo. Yes.
okay, Prof. How are you?
Thank you,
Thank you.
Dr.
Thank you.
Khalid.
Thank you. Okay, thank you very much. I'll be leaving. Okay, assalamualaikum.
See you.
Dr. Wirawan is the Vice Dean
Oh,
Student Affairs.
oh, okay, okay, okay.
Yeah.
Okay.
Okay, assalamualaikum.
I think.
Thank you, Dr.
Thank
Khalid.
you.
Thank you.